Hello, everybody. This is Daniel Suguwa, and yeah, uh, this is as promised. This is a new video that I've already talked about before, but I can say that because I don't have much idea and I don't know what to come up with, so I've decided, hey, let's go, let's get a let's get a topic that all of us can discuss a little bit scientific but mostly unscientific. I mean, like, it's it's something that in the science we discuss, but I can say that this is not the most scientific way to say to talk about. But well, what you gonna do? You need some material to talk about, okay? I mean, it's not that bad. Okay, so uh, come on, I'm just a little bit okay. Sorry for that. Not enough lighting, but whatever. Already tried whatever I can, just for this camera for to detect my movement, my VTuber movement and what's on. So, pardon for a little bit of weirdness here. And yeah, I think we can we can all agree about one thing, that water is very important. And maybe you're asking, well, why you're talking about water, because that's exactly the topic we are going to talk today. It's about water. Yeah, a little bit in the shitpost territory, but well, whatever, man. Okay, and I think we shall not waste too much time, so let's go here. Haha, presto. So let's talk about here. This is the water. You know, you guys know that water is essentially 70% covering all of our Earth so far. And also, as you know, the water, the fresh water isn't even that much. Around, if I remember, around 30+% like that. Yeah, and also here, yeah, correct. It's actually 30%, while the actual what fresh water that's trapped on Earth, on the glaciers, is actually 68.7%, which means you need to know that this water that's trapped there, it's not something we can use. Nor I can say that I can say it's not something we want to use it for now, because imagine imagine if all of that glacier, all of this glacier just melt down, going to the sea. It's somehow going to be a pretty saline solution, and that's the last thing you want to do. you the last thing you want to do is just to get everything, all of this fresh water just sip in, and you cannot drink the goody stuff anymore. I mean, in fact, around like 97%, the water on Earth is actually undrinkable. So only 3% pretty scarce, despite 70% uh, of the water, despite 70% of total water available in the whole entire uh, planet. This Earth. Yeah, and also forgot to mention that uh, that that scientists around last year, actually, we figure out how, actually, the scientists actually figure out that, let's say, if you do believe in this, in this, in the formation of the universe and what so on, it turns out, it says that the what the age of the water on the entire universe, or maybe our Earth, depends on your interpretation, is around 4.5 billion years old, man. I mean, like, how cool is that? It's pretty cool, you know. And also, speaking about the cool stuff, let me find here. Where is the one? No, 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 nothing to do. Ah, yeah, this one. Water can also be used, if you actually combine with carbon dioxide. You can use it to make something, let's say, for example, soda, or in this case, Coca-Cola, Pepsi, whatever fizzy drink you want to drink, especially if you like something a little bit like drink junkies and what's on. This is it, man. Freezy and very freezy. And yeah, I think we can go back to this fact sheet. It also says that uh, here that about 6,800 gallons of water, or us using metrics here, 25,740.8 liters of water is required to grow a day's food for a family of four, and that's what it says here. But could be a little bit more depending on whatever variable is it. It depends on what kind of let's say for vegetable, maybe fruits, what kind of crops you are actually growing in. But this is essentially like the best average. Yeah. And and don't forget that not only the 70% of the entire water on of our entire earth actually covered with water, but also even our brain is also have that kind of water. 70%, a more than 70%, maybe let's say 75, 76. Well, it's going to swallow your entire skull and what's on it. You're going to have a very very hard time. So yeah, do not overdrink, but at the same time drink enough water, especially in this very hot summer. I mean, even here in Sarawak, it's hot right now. you know it's hot. So take care of yourself. And yeah, usually, and also it says here that children in the first 6 months of life consume 7 times as much water per pound. What? I I mean, per pound. Let's say maybe around 7, 8, maybe even 9 times as much as water for per kilogram, or I don't know. A little bit confusing, imperial and metric stuff, but that's what it says. As the average American adult here, it says. And also, usually it says that we 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 also will lose a little bit more than a cup of water, or around 237 milliliter, if using the metric system, when we exhale it. Like, ah, you you figured that out. That's what I mean. That's what I meant. And yes, it says that hot water, it actually can freeze faster than cold water under some conditions that commonly known as the Mpemba effect. I hope I pronounce it right. Like here, for example, you see here, when you actually just throw around this hot water into this winter time, you just throw it outside. That's essentially the Mpemba effect. And here it says here, a swimming pool naturally loses around 1,000 gallons, or 3,785 liters a month to evaporation. So evaporation stuff is real here. A little bit nightmarish to handle stuff and what's on. So that's why present day, there is something what we there is I mean, if you have already heard about a plant, where a plant, whatever is it, where you hear they want to put a solar panel on top of this water reservoir stuff and what's on. This is the reason why, because they want to reduce the evaporation, while at the same time can be used it for, I don't know, keep drinking water on the tap, and what's on. I mean, you need to have some good water management. And also here, finally, yeah, the two finals here. I Yeah, here it says that household leaks can waste more than 1 trillion gallons, or 3 point or around 3.785 trillion liters annually nationwide. uh, this is the context of US, by the way, but you can imagine the whole entire world, I can say, can be way more than 1 trillion, way more than 3.78. at 5 liters of water being leaked and what's on, which it says according to the US context, the annual household can use that's the equivalent usage for the annual household water of 11, 11 million homes, which is why you need to take care of your water and what's on. Check on all of the leaks and what's on, so you can lower the bill consumption, and also you can ensure that everyone else can use that water. It's not only you going to use that water, you will also use that one. And also it says that 2/3 of the world's population is projected to face water scarcity by 2025. That's what the United Nations or UN said, uh, which is not going to be that long. It's less than 2 years from now, so we will see how to use that projection so far. And yeah, I think I make it too long. Yeah, but whatever is it, I think we can also discuss a little bit slightly unrelated stuff. For example, this stuff, this salt, when you actually use this salt, when you try mix it with the water, it can actually change the temperature, slight slightly depends on what how many kinds, how many salt is in there, like how many grams is it, or ounce, whatever. I'm a little bit confused on imperial stuff here, but just for for every 0.5 degrees Celsius uh, boiling temperature changes there, going up there, you need to put around 58 grams of salt. So yeah, that's one of the answer. Maybe you said like, hey, why that stuff actually increases? Well, why the temperature of the why you can lower the temperature in the cold stuff, but cold in the cold environment, but when you actually try to use, let's say you want to use it for the hot one, it will take a lot of energy. You want to know why? It's around, should be here. Oh, okay, maybe I'll cover that later. Here, as you can see, the bond of the hydrogen is a lot. Okay, it's a lot, around here, like let's say, because hydrogen, the negative ion, actually attracted a lot to the chlorine, which is also have negative ion. But you can see there is one problem: the hydrogen atom, the two atom of it is actually way smaller compared to, let's say, oxygen, which the positive one can bind with the uh, natrium or sodium, which is also positive one. As you can see, if you see uh, the bond of it, you know I mean, despite it's lower, but try imagine this. uh, yeah, I think I get facts mixed up, but whatever. As you can see that, because hydrogen, uh, because imagine you have double the amount of iron. When you try to separate this stuff, let's say hydrogen and even the oxygen, when you try to separate this, what do you think about it? It's going to take a lot of energy, okay, just to cut off all of this tie. And because of this one, when you try to boil up those water, it will essentially raises the temperature needed just to get that same amount of water being boiled down, as, let's say, comparable, as comparison to, let's say, if you are using distilled water, or maybe, let's say, maybe even mineral water, you know but well, it looks like I'm talking slightly a little bit more, right? Yeah. And yeah, I want to cover a lot more about, let's say, for example, about this ice cream. Yeah, which is maybe you're asking about why ice cream, or let's say something uh, like the ice cream emulsifier. Let's say for example you're using the egg yolk and also the buttermilk as the result of a little bit when you left off this butter stuff, eventually will become this one, buttermilk, which the buttermilk you can see it's like much more viscous and leave residue compared to the milk. Okay, and also about this soap, you know why? Because why it can mix in the water? Because here, hydrophilic head here. This one, the hydrophobic tail, it essentially becomes the bridge. When you want to soak up all of this oil or protein, you want to attract it there. You can just use the hydrophobic tail, or what we like to also call it as lipidophilic tail. Here is this stuff here. Just for your information, the philic means likes or attracted to. So we can just use the word lipophilic or hydrophobic. Either of these is okay, and hydrophilic or maybe lipidophobic head here. Yeah, whatever is it, but you get the idea. This one loves oil or whatever protein stuff here, and here it likes water here, and because it can actually combine between these two, you bridge out between you bridge between this non-polar here and also the polar one here. That's essentially the reason why sometimes water can mix sort of mix with the soap or maybe even ice cream there, if you prefer to make it without alcohol. But if you want to make it with alcohol, go ahead. I'm not going to judge you much. Okay, and also even the vinegar, the same application can be said. uh, yeah, I think that's all I want to cover. Not so much to cover so far. Yeah, as you can see, because I don't have much idea, but well, that's why I said I want to talk something scientific in the most unscientific, a little bit casual stuff. But well, whatever is it. Let's just say I don't entirely 100% know about that topic, so that's why I show you that screen instead, because I don't like to pretend I know everything. But well, whatever is it, I hope you guys learn something about why we all love about random facts about water, and why I love waters, because yeah, water is very important unless you want to get sick. Okay, and also if you can please just drink whatever the sky juice, the sky juice, the water one, specifically mineral, or you drink the electrolyte is like, how do I want to call it? I call it as the as the mineral on steroid, essentially the super mineral water. That's what I like to call it, but hey, it's funny. Yeah, so that's all random facts about water and what's on. And I hope I will able to see you guys there. Bye bye. And yeah, if you can, maybe please subscribe to my channel and like this video. Well, even though I don't like to give this reminder about whatever, man, a little bit for algorithm. But that's it, guys. This is me, Daniel Suguwa, signing out, and please take care of this hot summer. Okay, take care. Bye bye.